Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're going to be doing a walkthrough with the Revopoint Inspire2 3D scanner. And so we recently did a review on this device. We talked about how it is an upgrade from the original Inspire, and this one has the addition of a laser line mode. And so what we're going to be doing in this video is we're going to walk through two examples. We'll be doing a feature-based scan mode with the structured light scanner, and then we'll be doing a laser scan mode. And so one of the most common questions I get on the channel in regards to just scanning in general is that how do you get a good quality scan? And we've done a number of videos on this. We recently did one talking about getting the best scan out of a Metro Y. And this is going to be really no different. But with every new scanner, there is going to be a learning period. You're going to have to understand how it works, how to get the best quality scan out of it, and what are some of the things that we want to avoid. And so for this, we're going to be doing two examples. I'm going to be doing this portion of this Mitsubishi thermostat housing. So this is going to be a laser scan part. I've got a couple of marker dots on here. And then we're going to be doing this motocross handguard. And so these are things that we've scanned before, but they're good examples of what works for a certain type of part, the part size, the features, and things like that, and what doesn't. Now this handguard right now has scan spray on it. It's not typically required. This handguard is actually white. I have an orange version that scans better without the scan spray on it. But scan spray in general will make the scanning process so much easier. And so Revopoint has a couple of different options. And generally what I do is I've got a couple from them and I've got a couple from AppBlime. And the vanishing ones are a little bit more expensive, but it really helps on the cleanup side of things. So you can make your own with like acetone and baby powder, for example, put it in a squirt bottle, and then the acetone will off gas and leave the powder behind. That can also damage paint. You have to be careful with any of these things because the carrier, the liquid generally can damage paint. These scan sprays are typically a little bit more safer than the at-home concoctions if you are using something like acetone and you're spraying it on a vehicle, for example. So for our parts, for the laser scan, this is a cast aluminum part. It is sandblasted and it's got a couple of marker dots on it. So we're going to scan this with a laser scanner. I haven't actually scanned this part before. Generally what I do with these videos is we do it in real time when we're doing a how-to video, and that's what we're going to do here. So we'll talk about the number of scans, orientation, merging multiple scans together, and getting that final mesh model. For the handguard, what we're going to do is focus on some things to watch out for when we're using the structured light scan, basically the feature scan. And what I found with the Inspire2, the feature scan typically captures at 15 to 20 frames a second. But if you want a high quality scan, you generally have to sort of hover for longer. And really what that means is if you want to bring in enough points to get a fine resolution of your design, whatever you're scanning, then you just need to kind of hesitate or wait a little bit longer. With the laser scan, we have the color changing that happens on the screen, so we have a good indication of how many points we've captured. Okay, so with all that said, let's go ahead and get started. We're going to start with the feature scan, because I think most people will start with that, and then we'll move on to the laser scan afterwards. All right, to get started with the feature scan, we're not going to be putting all of the, assembling the scanner, plugging it in, getting it all set up. That's all pretty straightforward, and there's a lot of resources from Revopoint on how to do that. I don't think it's worth the time to do it in this video. We're going to focus on the scanning itself. And so with a feature scan, generally what we're going to be doing is positioning the object where we can scan as much as possible. Now, it's not always possible. Sometimes we just have a little bit more difficulty with that. This handguard is a good example. If I don't hang it from something or clamp it in something, then it just kind of sits on the workbench in this case. And so what we're gonna do here is go over a typical scenario where you really can't position it very well. So what we're gonna do is we're gonna scan the top, which will get the Cerebis logo in it, and we'll flip it over and we'll scan from this side, which will get that logo as well. And that's key because that's what we're going to be using to align multiple scans. And so with those two scans, we'll be able to put together a scan of the front. Now this is a thin part. Thin parts are really difficult to scan around the edges. If we want to, we could scan the back, but for this video, I want to keep it shorter. I don't want it to be an hour long just to do these scans. And since you don't have this at home, there's really no point in going all the way through it. So what we're gonna do is, again, do this in 2 scans so that we have enough to align. And so the first part of this is to start a new project. So I'm gonna call this my Acerbis handguard. And when the scanning process is starting, I'm gonna go ahead and move this a little bit here so we can get a good idea. When the scan process is starting, there's a couple of things that we want to be aware of. The first thing is going to be our settings. So we're in full field mode. That's the only way that we're gonna be doing a feature scan. And then we've got high accuracy or high speed. Because this part has a lot of intricate little details, I'm gonna use high accuracy, which is slower, but it should bring in more points, a denser point cloud. So we'll leave it at high accuracy. For a part like this, you probably don't need it, but it's good to play around with your own different objects. For the settings here, we're going to use general because this does have scan spray on it. If it was black plastic, we would use dark. Now I found that this does a decent job with black. I did some scanning on my mountain bike a little bit ago, and it has a RockShox Lyric fork, and the fork brace, I'm designing a 3D printed fender for it. And the fork brace and the fork, and even actually the sort of shiny stanchions on the fork, those all scanned pretty well in dark mode. And it does mess with the exposure, but that's something that you want to keep in mind. If you're scanning your face, then obviously use the face option. If you are installing the filters that go on the outside of this thing, you can use the outdoor object option. But again, for us, we're using general. I am going to toggle on base removal. This is a really nice option to have, and it's only available when we're doing the full field scan. Currently, it's not available on laser scan. I hope they add it at some point, but right now it's not. And then the next thing we want to look at is the exposure. Down here at the bottom, the exposure and the white balance, I'm not too worried about those because we're not capturing color. If we were capturing color, we would want to enable color scanning. Because this thing has white scan spray on it, it doesn't really do us any good to capture color. But a quick point on that is if you are scanning something that does have color, it will actually help the tracking. So for example, if we looked at my hot cocoa mug here, this is just round, but the logo would actually allow it to attach a color to that point in space, which means that when it's scanning and when it's going around an object that maybe doesn't have very many features on it, it can actually use the color to help it with that tracking. And so for this, we don't need to worry about it. We're not doing color scanning, but the depth exposure is important. You can manually set it. And typically what you want to look for is the object on the right-hand side. We've got sort of the distance bar. We want to be in the good or excellent range. And then we want the object on screen to just very slightly start to turn red. And so you can see at 3, it's pretty red, but as we go a little bit further away to the good area, you can see it's kind of starting to get that speckled red. If we go down to 2, as we get closer, you can see that it's getting that brighter red. So once we're in the excellent range, it seems like the exposure of 2 is a better option. As we get further away, the exposure of 3 is. You can use the auto option, and what I found myself doing with this scanner is using auto more than I do with any other scanner, because on the back it only has a play button. I can't manually adjust the exposure on the fly without coming over to the computer. So I tend to use auto exposure a bit more on this scanner than I do with others. And then the next thing we want to do is just get close. We want to start with a frame that has a lot of features. And once we're aligned and in the good or excellent range, we'll hit play and we'll start capturing. And so typically with the first frame, I'll kind of hang here for a few seconds, and then I'll start to move my way across the part. And again, really what I'm looking for is to get the sort of embossed logo here, and then I'm going to work my way around. Because of the really dense venting that's happening on here, that's actually really tricky for us to scan with something that is at this resolution for the full field mode. So that's something that these will likely get filled in just because of the nature of the way it's scanning. But for the most part, everything else picks up pretty quickly. Now, what I mentioned earlier is really what we want to do is we want to kind of hang out for a little bit longer to get more points. And you want to try to keep the scanner perpendicular to the part, or perpendicular to where you're scanning. Now if I rotate this around, you'll see now that I've added more frames, it ended up filling in those areas. And so what I'm going to do is use undo. I'm going to go back a few frames because I don't really want to fill those in. I want to keep it as accurate as possible. And then I'm going to go back, let's just see a couple more. I'm going to go back to a previous view, get back to a good distance, and then I want to start making sure I capture enough points perpendicular to all the geometry, and I'll say OK. And so when we look at this preview on the screen, a couple things that we want to note. This area where I went back and scanned more, which is kind of the area where the mount is, you can see visibly on the screen, I've got a much denser set of points. On the side over here on the left, I don't have nearly as many points. And so this could potentially be problematic, and it might mean that we don't have enough data. So it's always good for us to scan more than we think we need, because it's much easier to scan a little bit extra than it is to have to reset everything up and come back. So I'm just gonna, again, hang out here, try to stay perpendicular to the part, and say OK. And now that looks like it's filled in a little bit better. Whether or not this is a good scan, I'm not really sure. We're just gonna have to review it. And once again, I'm not gonna spend a ton of time trying to go around these edges. If you were going to try to get a good front and back scan of this part, you might wanna do that. For us, it's really just an example of sort of general practices for scanning something like this. So overall, I think it looks okay. Obviously, there's stuff missing at the bottom. The base removal didn't work perfectly. There's still some stuff left, but it's isolated. It's not touching, so be easy to remove. And you can see those vents ended up filling themselves in. Now, this is really where having something that has a smaller point distance, so something like a 0.01, 0.02 millimeters, which we could get on laser mode if we use marker dots on it. But with the full field mode, we are just having a little bit of trouble capturing those. So what I'm going to do is I'm going to do another feature scan. So we're going to say new scan. We'll use all the same settings, once again, turning on auto exposure. I'm going to once again get back to a good distance, a good view, let the exposure reset itself. Once again, it's going to go back and forth between 2 and 3. We're going to start here, kind of work our way up. And once again, with pretty much any scanner, but it is especially important for us to remember that we really need to be perpendicular to the surface we're scanning. So as we roll into these corners, while it looks like it's capturing points, we really want to go up and be 90 degrees to that surface. And that's something that we always need to keep in mind. So I'm going to go back and scan just a few more frames over here. Just want to make sure that we're not missing anything, kind of roll up. And then work my way that direction. So as you begin scanning with this scanner, or really anything, it's going to take some practice to get good at, one, keeping the scanner perpendicular to the surfaces you're scanning, but also keeping a consistent distance. This is tough because, especially if you have a tripod or something like this, or a handle, and you're scanning in this orientation, you can get to a point where you really can't go any lower. You can flip the scanner over, but you want to do it slowly because you don't want it to lose any tracking. All right, just for good measure, I'm going to do one more scan of the back side. Let's go ahead and maybe set it up in this orientation, just so that, again, that we have a little bit of practice. So auto exposure, get to a good view, and get started. And once again, we want to play around with the distances, kind of move around, trying to keep the scanner in that good or excellent range. And this is going to be tricky because of the mount is there, which means it's blocking some of the depth camera. And so these two cameras, these two depth cameras, they're both looking out and capturing the grid that's being projected on. We're not actually seeing the grid in this case because it's not blue or visible light. And that's what's being used to basically figure out where everything is in space. Kind of like our eyes, we've got two cameras, and both of those cameras have to see what we're doing. So on this object with this clamp right here, if I'm scanning like this, the clamp portion is blocking the cameras from seeing the same thing. And so that's a situation where we really need to work around like this. Probably remove that would be best if we weren't scanning it. But these are, again, all things that we need to consider. And this is where we run into problems when we're trying to scan like into a deep hole or a crevice or something. All right, so let's go ahead and complete that scan. Now, typically I go through and I process these later, but these should process fairly quickly. So what I'm going to do is run through Fusion, and I'm going to use the default settings for point distance. For a part like this, it would generally be 1 to 2 minutes. It doesn't take very long. So we'll just let it do this. And this point of the process is where it takes all of the points we captured, every frame, and then any that are closer than that 0.71, it's going to fuse them together as one point. And now that we've got the fused points, the next thing is to do isolation detection. And you can see it picked up all of that extra stuff that's kind of floating around. Anything that we have where we've got really bad quality scans, so this stuff that we didn't really capture or didn't intend to capture, it's a good idea to get rid of it. And so what I'm going to do is just create a couple of cuts and then hit delete. I also always do overlap detection. And so overlap detection, didn't find anything here, but overlap detection is what happens when we're scanning and we go back to an area again, and the point actually ends up being a little bit on top of the surface. And we want to make sure that we don't have that because it will affect us downstream. So with the second scan, we'll do the same thing. I'm going to apply Fusion. Once again, it's taking all of the points. If you think about a full field scan, it's going to be capturing a grid. And actually, this is probably a good representation of it. And so it's actually going to be capturing a grid of points. And if some of those points are close together, like these two or these two, which these are marker dots, obviously, but if those are close together within that 0.71 distance, it can actually fuse them as a single point. So we end up with a more continuous grid of these points. And as we move into turning them into a mesh, that's going to be important. All right, so now we have this. We'll do isolation. It's not going to take care of the base in this case. It'll take care of some. Again, the top we don't need. This was the bottom scan. We only need some of it so that we can align, and really it's just the logo. So all this bottom stuff, I'm going to go ahead and cut. And I think I'm going to cut this out as well because this will end up causing problems when we merge scans together. And then I'm only going to do these two. I'll do overlap detection. And it found a couple of points. And then we'll move over to merge. Now merge is where we're going to take the two scans and we're going to use a basically feature alignment. And what feature alignment is doing is it's looking at geometry, and then the geometry itself is how it creates the alignment. If you have to do this manually, you need to manually pick points that are close to the same area on the part, and it'll use those points to get close. But really what it's looking at is going to be the triangle or the points themselves and the geometry that are created from those points. So once we have this, we can move on to the mesh step. So we're going to take merge and I'm going to mesh it. Now I've talked about this in the previous video about smoothing and simplification. I generally don't do that at the point level. I usually leave that for the mesh level. And we talked about it in that longer video about getting the best scans from the Metro Y. If you want to learn more about those steps, I suggest checking that video out. In this case, I'm going to use high quality mesh. Fast mesh is quicker, but it'll be less accurate. In this case, it's not going to take very long. Grid size, I'll use the default that it's setting here at 4.7. 4.7, that number is basically a quality slider, and it's going to give us a mesh element size of about 0.5 millimeter. And you can see there, now we've got our mesh. Let's go ahead and rotate this around. This is really a pain on a trackpad or like a touchpad on a laptop. But you can see it ended up filling in those pockets. Again, with the resolution in full field, we don't really have, we're not capturing enough data in those areas for it to know that those are vents. And so that would really be something for a laser scanner to do. But the rest of it looks pretty good. It's always a good idea to go to display and go to wireframe overlay to see what your mesh looks like. We have got right now 227,000 polygons. And so what we can do is run through isolation on the mesh. No data was found, that's good. We can go into a smoothing. If we have any areas, this is a typical problem that people have with scanning in general. When you have a really dense point cloud and you convert that to a really dense mesh, it ends up having a lot of these wavy sections. And with the wavy sections, it creates this situation where the scan itself looks pretty bad. And we fix that by doing smoothing and simplification. And so if I turn the display back to solid and take a look at the resolution here, it's a fairly low resolution, but what we're gonna do is just run through strength and times. We're gonna go through one time, let it clean it up a little bit. And again, that longer video, if you wanna learn more about what those settings do, we talk about that a little bit more in depth. And then simplification, when I do this, I always go back and turn on the wireframe overlay. And this ratio here, it's gonna take us from 227,000, and we're gonna go down to 40%, so 136,000. And we can see that we've got higher density near the letters, and the bigger, broader faces are getting a lower density. And you can repeat this as many times as you want, but at some point you are gonna end up losing some detail. So you do need to be careful, but in general, most, let's see, I'm gonna turn off the wireframe edges. So you can see at this stage, the surfaces look really smooth, but the letters are really blocky. So I'm gonna undo, and I'm gonna undo again, and maybe one more time. And so we have to kind of play around with this and figure out what we need out of this model. And if we need just the big clean surfaces and we don't care about that embossed logo, then we can go kind of crazy with this. Now what I'm gonna do is I'm gonna export this mesh. And let's see, I will save it. Let's go over here. I'll just stick it here as an STL. And we'll just call it handguard. And so I'll leave a link in the description so you can download that if you want to. Go ahead and say okay. All right, so now that we've taken care of the feature scan, let's go ahead and move on to a laser scan example after I get a sip of cocoa. All right, it's been kind of cold and windy here, and it's not too bad in the garage right now. All right, so the first step to know when you're doing a laser scan is we need to have marker dots. There's no way around it. Now, one thing you can do is get a plate, whether it's a black mat like this that I have with some marker dots on it, or a larger plate like this. I've got smaller ones on the back side, I've got larger ones here. This is a good idea because if you want to place it on a workbench or wherever you're working, that's fine. But this is a good idea because this gives us a surface where we don't have to put markers on everything. Now this part I actually ended up putting 2 extra markers on this face here, which was fairly flat, and this face here, which is fairly flat. And the main reason is because as we're moving around the part, the height of this object can cause problems to basically to this base plate. And so with something that's this high, let's just say, 50 millimeters or 2 inches or so, it's a good idea as you get further away from this base to throw a marker on as a reference. But you always want to put it on a flat face and make sure that it's not next to an edge. In this case, there are casting marks and things like that, but we want to make sure that it's on a flat face where it's easy to remove. With the laser scanners from Revopoint, they have a new highly reflective or more reflective marker dot that works better, so it gives you a steeper angle that you can get to, and I would suggest using those. For this part, I'm going to use this smaller mat, And that should give me enough marker dots, but I'm gonna rotate this part slightly. And what we're gonna do is we need to do a couple of different scans. So we're gonna scan it in this orientation because it's got a nice flat base. This orientation, what this is gonna do is it's gonna allow me to scan this side, because when it's here, I'm gonna have to cut the bottom off because of this, this plane here. Same thing here, when I scan it, I'm gonna have to cut the bottom off, so I wanna make sure to grab that. And then I'll probably do just a couple of other random orientations so I can try to get into some of these crevices. I haven't scanned this part before with the Inspire2, so we're gonna, once again, do it live in real time. And the same thing with the handguard. We kind of, went through it live in real time. So that way there's not really, I'm not faking it or trying to give you an ideal example. This might not work very well. I think it will. I've scanned it with the Metro X and the Metro Y. So I think it'll be fine with the Inspire. So let's go ahead. I'm gonna turn it this way. That way I can get to this side a little bit easier. We're gonna start a new project. This is gonna be my T-stat base. And we are gonna be doing a laser scan. So first thing that we wanna do is change to marker scan in the top left. Marker scan does let us still use full field, but in our case, we're gonna use the markers and the laser, and those are gonna be a bit more accurate. And so when we're setting up for a laser scan, we have the ability to give us a target point distance. That's gonna determine the color that changes on the screen of the RevoScan software, and Revo Metro in this case. And so what that'll do is it'll indicate to us when we've captured that density of points. And so you can set this to whatever you want. I think for a part like this, 0.5 millimeter is probably going to be good. I'm gonna manually set it here. Let's go ahead and go down. I really don't like working on a laptop if I don't have to. We're gonna be doing parallel lines. Once again, you can use full field if you want. Marker tracking. A global marker file is where you pre-capture all the markers. And so it generally speeds up the scanning, and it actually it'll be good for us to go through a global marker. The next thing is the object type. This is general because it is a sort of a dull cast sandblast aluminum. If it was black, whether it's shiny or matte, you would want to use the black option. This changes the laser intensity and exposure. There's a metallic shiny option here, and also outdoor, again, if you're using those filters. And so for us, what we're gonna do is select new scan for the global marker. And then all we do here is we're capturing just the markers. And so you still wanna be in that sort of good and excellent range. And it's gonna create a file that has all of these markers. So you wanna go around and make sure you're grabbing every marker that's on this part. So if there's one on the side over here, we wanna make sure that we get it. And once we have all the markers, now what we can do is say complete, and it stores all the markers, so that way we're not capturing those at the same time that we're scanning. So it'll be a little bit quicker for us. Once we have those, what we do is we say cloud scan, make sure all of our settings are okay. So the point distance you can see went back down to 0.3, which is the default, and we'll say cloud scan. So it's gonna use that global marker file that we captured, and over here, we've got our laser brightness and depth exposure. There's not an auto setting right now, but those are set to a kind of a default. And what I would say with this is play around with the depth exposure. Once again, we're kind of looking for those red highlights. It's a little bit trickier to see because it's only a single line, but those red highlights will help us better understand. Go until you are in the sort of green, again, good, excellent range, and then hit play. And so now because we got the global marker file, we can kind of move around, in most cases, as quick as we want without fear of dropping frames. It's not a perfect solution. Like there are some cases where it might lose, but for the most part, this is gonna be a fairly consistent way to ensure that we're not dropping frames. You still wanna be in that good distance range, so between 200 and 400 millimeters, and you still want to be perpendicular to the faces that you're scanning. And so here we're going to go back and forth. And once everything turns blue, or in this case, when it goes from orange to blue, that means that we have captured enough data to have 0.5 millimeters. One thing you'll notice as we're laser scanning and it's capturing the base and all this other stuff, it's a little bit harder for us to tell the distances because the distance to the top of the part is fairly close, so it's in the excellent range, and the distance to the base is far away or further away. And so you have to kind of understand that bar on the right. You need to pay close attention to the object you're trying to scan and the distance that you are away. So I'm going to just work my way around the part. Remember, we're going to flip it over and scan from the other side. So I don't need to capture everything, but I'm going to roll over the top, make sure the cable's out of the way, and make sure the markers are still there. Now, one downside to the global marker file, in this case, is 2 of the markers are on our part. So we can't reuse that global marker file again. We're going to have to capture another global marker file because the orientation of those marker dots on the part is going to change. And also the ones that are covered up under the part are going to change. Now I can actually filter out a couple of points, but in general you don't want that to be the case. I'm going to try to get underneath that, see if I can. All right, so we'll pause that, and that looks pretty good. Now, without talking and explaining that, I could have gone through it a bit faster. I'm going to rotate this around, kind of zoom in. That looks pretty good, so I'm going to say complete. So then the second orientation, I'm going to flip the part. Once again, now these 2 marker dots have changed positions, so I need to recapture that global marker file. And so what we're going to do is under the global marker tracking, we're going to go to new scan on the left side. And so that new scan on the left side under the global marker is going to allow us to, again, capture some new markers. So the base is going to be the same, but the side is what we want. So let's go ahead and go here. We'll grab that one and try to get around the back side. There we go. And pause. From there, we'll complete. And once we've captured everything, make sure that our settings are correct. So again, parallel lines, global marker, general, and we'll do a cloud scan. Now, if you do have a plate set up and you've got markers around it that are fixed and there's no markers on your part and the center is covered up the same, you probably don't need to recapture the global marker. You can use it again. For our purposes, I recaptured it again for those reasons because the markers on the part changed. So depth exposure is still the same, laser brightness still the same. Again, you can play around with those. It will depend on the surface finish and color of your part, as well as the ambient lights wherever you're scanning. And so we're just going to start this. And again, with the global marker file, we can go fairly quick, try to get to that good and excellent range. Once again, it can be tricky if you have a taller part because as it captures the base or whatever it's setting on, in this case a workbench, it's going to think that it's further away and cause problems. So we're just going to do this kind of slowly. I'm not sure if you can pick up the sound, but it is very windy outside and my garage doors are rattling pretty good. All right, so tracking lost. I'm going to make sure that it can see. It can be very easy to forget where things are because a lot of times the depth camera view is really dark, especially in laser scan mode. But you can see a preview of the laser lines on the screen, and that's generally what I go by. If I happen to lose where I am, then I'll use the depth camera one, but I generally use the depth camera one a little bit more when I'm using the full field because it's easier to see the object. I'm going to try to go around the outside here. Another good thing, which I'm not using in this case because it wasn't part of the kit, is the 3D markers. And so those come in the Metro X Advanced kit. I believe they come in the Metro Y. There's an accessory that you can get for the Metro Y or for this Inspire2. They are extremely handy. They're magnetic and they can, if you're scanning something on a car, If it is steel, then you can just put them onto that car, and they're really helpful. And they can just sit around the part. And the reason that's helpful is because as you tilt the scanner further, past 45 degrees relative to your workbench, you can actually end up losing the markers. Even though it can still see them, they're not nearly as reflective. And so this scan isn't as clean. You can see there are some issues on the sides, but because I know we are going to scan it in multiple other orientations where I can get a good reference shot at that, I'm not worried about it. And so now what we're going to do is we're going to do another scan. So we're going to say new scan. Actually, you know what? Let's cancel that one. Instead of doing another, we'll do a new scan, but instead of doing another global marker, we'll just do a regular marker tracking so you can see how that works as well. And so once again, play around with the depth exposure. You want the laser lines, which are going to be hard to see, and the good and excellent distance, you want them to just barely have that tint of red. And if you want to increase the laser brightness, I'm going to go ahead and kick this up a little bit. Again, that's going to be dependent upon the surface finish that you're working with. And so here I have to be careful, because if I move too fast without that global marker file, I'm going to end up dropping frames. And so because it's capturing the markers and the part at the same time, it's actually going a little bit slower, and it's not noticeable as we're moving back and forth on the part. But when I say it's going a little bit slower, what I mean is that the color is changing on the screen slower. And so it's having trouble with tracking. You can see that it's starting to lose tracking because of the angles. So I'm just going to move slowly around the part, kind of work my way over here. What I'm trying to do is get on the side of that boss, which I've already scanned it mostly, but it's always good for us to have, again, a couple of extra frames. Move back and forth. Remember, with laser scanning, it's only pulling in data where the laser is. And so as you move around your part, you need to kind of be aware of that. So we're going to call it there. Not a great scan, but I think it really highlights how much of a benefit the global marker is. And so I'm going to try it in this orientation now. There's no markers on the part, so I have to rely heavily on the markers around it. And so what we're going to do is change the tracking mode to global marker. We'll create a new global marker file. Once again, you can reuse global marker files. It is completely dependent on your setup. And so in this case, move around. And what you want to see on the screen is all of the markers. Red will be when you're capturing them, and you want all the markers to be displayed on the screen, all the ones that you can see. Now, if you miss a few, not really a big deal, but you definitely want to make sure that you capture them around the part. I'm only going to be scanning this from this orientation, so I'm not too worried about it. Once again, I'm going to increase the resolution to 0.5, or the target point distance, I should say. And then get to a good distance and start scanning. And so again, with the global marker, you can see I'm just kind of going back and forth much quicker. And it's not having to capture the points and track them at the same time. And so it is a quicker experience. It doesn't mean that we can just go crazy, and it doesn't mean that we won't still lose tracking, but it is definitely more robust. Let's move back and forth on this part. Tracking loss, so just wait. Another benefit of the global marker, when the tracking is lost, unlike if you're capturing the markers at the same time, it doesn't necessarily jump around and mess up the frames of the scan, because it still knows where it is relative to the global marker file. And so it's a little bit safer in terms of the quality of your scan. So I'm going to scan as much as I can. If I can get underneath this boss, probably not because of the angle. And even though I didn't capture that marker on the bottom in the global marker file, it still was able to use it. We'll go around this way. And then the more that you can capture in every frame, the better. It'll help with alignment. And sometimes you'll find that there are certain angles where you can get into deeper features, or you can capture things that you maybe missed in another view. And then when we allow it to do its alignment, it'll just create a better quality scan overall. So now I'm moving back and forth. I'm trying to get, I'm going to pause it so my finger doesn't end up. I'm going to try to get into this screw hole here. So I'm going to work my way around, kind of scan this side as well. Again, kind of watching that distance. We want to make sure we're always in the good or excellent range. And then work around this way. There we go. All right, so now we've got plenty of scans. Let's go ahead and complete this. I think I got everything. I did it from this, I did it from there, I did that side, I did this side. So that's probably good. But once again, it's always a good idea to make sure that you are capturing as much as possible. Cocoa break. I don't generally process on this laptop, but for this example, we'll go ahead and do it. All right, so the first scan, we've got this large table here, and this would be so much easier with a mouse. But you'll notice that there are some points that are floating above it, and that noise tends to happen when the surface is slightly reflective. The more reflective the surface with laser scanning, the more noise that I've noticed with the Metro X, the Metro Y, and this Inspire as well. You don't seem to get it as much with full field scans, but definitely see it a bit more with the laser scans. And so one thing we can do is we can batch process these scans if we want to. It ends up taking a bit of time, and so I'm going to do them one at a time. But so for example, if we were to batch process just the fusion portion of this, we'll select all the scans, we'll do a high quality fusion, we'll pick the point distance, and so it says recommends 0.23. So even though we had the scan preview set at 0.5, we actually captured enough points that we can fuse them down to 0.23. I'm going to fuse it at 0.26, and we'll let it go, because this is going to happen on all four of those. And so that 0.23 means that on all four scans that I really captured enough data. If I had set that slider down at 0.2 or 0.3, that just means that's the point when it'll change from that orange to that blue color. And so we just have to sit here and kind of wait for it to happen. Some other things to consider when you're doing this, and again, we've talked about this in multiple videos at this point, is figuring out what point distance works best. In that Metro Y video where we talked about getting the best quality scans, we did the same thing, or we scanned the same part at 3 different settings. We went through and processed them all, and we looked at the results. And basically, you just have to decide for your part, for the features and the level of detail, what is a good number for you to use. It's the quality of like a complex surface, for example, is going to be better if the number is higher. Now, that doesn't mean the accuracy, it doesn't mean how close it is to the actual part. But in terms of the surface finish, the smoothness of it, you will generally see a much smoother finish when you have a larger number. And that's because essentially those points and everything is much further out, so you don't get all the little high and low points in those scans. And so for us, with a mechanical part, this one has several threaded areas, and there are deep areas inside, and there's some ports and things that we need to capture. Generally with something like this, we need to set that number a bit smaller so we know that we've got enough points to make it happen. It doesn't mean you have to set it as low as it'll go, but play around with it. 0.5 is a good general number, a general starting point. And then you can always scan longer. So if you set it at 0.5, you can keep scanning and capture more data. And then you can see, even in this case, we were able to fuse it down to 0.3. And so just play around with it. It's always a good idea, especially when you're getting started, to begin in sort of the middle, 0.5, scan the same object, in the same orientation at 1 millimeter and then scan it at like 0.2 and process them and figure out what works for you, which you'll find, again, on larger parts, car fenders, things like that, you're gonna set that number a bit higher. And on mechanical parts where you have to capture intricate details, you wanna preserve sharp corners, you're gonna set it a bit lower. And so in this case, again, that's what I was saying with batch processing. We're going through all 4 of these at the same time. We've only fused 2 of them. And so it's just a process that takes a while. And so as you're doing this, as you're trying to figure out what works for you, it's just a matter of playing with it. Now, if you have problems with RevoScan itself running on your computer, that's definitely a technical issue. You want to reach out to Revopoint and make sure there's not a problem. There are updates to the software all the time. A lot of times they fix bugs. There was an update to this today that I saw for bug fixes for the Metro Y and the Metro Y Pro. I didn't update it just because I'm scanning with the Inspire, so I don't really have to worry about it. But those, sometimes reporting those things can help them identify a potential problem that gets fixed and pushed. Another thing to keep in mind, or 2 things really, firmware for the scanners. When your scanner's connected to RevoScan, if you're using one of the basically structured light scanners, or Revo Metro for the Inspire2, Metro X, Metro Y Pro, or the Track It, Revo Track, if there's a firmware update for your specific scanner, then that will also likely have an improvement in performance and accuracy. And so if you're prompted to update the firmware, I would suggest doing it. I know I get them over-the-air updates for things like the Morocco all the time. Well, not all the time, but when it seems like every time I turn one of them on, there's an update to the firmware. Another thing to consider is calibration. Every time you get a scanner, you should start by calibrating it. I have had several scanners where I've gone and started scanning without calibrating and it's been perfectly fine. And I've had a few where I didn't calibrate and I ended up getting shifted frames. So if you're scanning a casting or like the handguard that we scanned, what you would see is the letter, like the A and the logo, would be shifted. And so you get some scan data that was correct and some scan data that was shifted a little bit. And that's a calibration issue. And so if you're scanning something, especially if you notice there's text or a specific feature like a boss that's sticking up out of a part, and it looks like it's kind of got double vision or it's shifted around, that is a calibration issue. Potentially a firmware issue if it hasn't been updated, but most likely a calibration issue. So every time I get started with a new scanner, a brand new one that I've just opened, I'll do a calibration on it. And it doesn't take that long unless it's the Track It takes quite a bit longer. We'll talk about that in a future video. But things like the Inspire2, any of the Metro series scanners, the Morocco, all those, the scanning calibration process is not that bad. All right, we're still only 3 through. So we've got 1 more to go and then we will talk about the next step. With any scanner, specifically with Revopoint, but in general, the process is going to be very similar. The setup is going to save you a lot of time. So if you prep your parts, if you use scan spray, if you have a well-lit setup and you've got enough space to get around the part, that's the first step in the process. The second step is to make sure that everything is calibrated and connected and set up properly. And then the third step is to make sure you capture enough. So I always suggest capturing more than you think you need. And so if you're scanning and you think you've got enough and you shut it down, if you're like me, you scan with a laptop and then you take it to a desktop to process. There have been several times when I get up to my computer and there's like a hole in the scan, or there's an area where there weren't enough points, so when it fuses and it goes to mesh, there's a hole or there's an issue. And so it's always a good idea to capture more data than you think you need because it will save you time in the long run. And so, those general steps they're leading up to the process before you ever really get into finalizing a scan and turning it into a mesh, but making sure you do that setup for everything you do will hopefully save you some headaches downstream. All right, Now that we got all of these, the next step is to clean this up a bit more. And so you can see there are shadows or holes under the scan. And what I want to do is get rid of everything on the base. So I'm just going to cut basically everything down here and delete it. And then I'm going to run through isolation detection. Now, remember with full field mode, there is a base removal, an automatic base removal. It works pretty well in most cases. If your base is not perfectly flat, like this, this workbench is made by like 2x8s, and this one is a little bit lower than this one. It tends to have trouble with that because it doesn't know that it's actually flat. All right, so there's a little bit. Let's go over here. So I'm just gonna get rid of that, and then run overlap detection. So same thing we did with the handguard. I'm going to run through those steps with each scan. Now, again, you can do some batch processing. You can't do batch processing on the manual cleanup, so the trimming that we're doing here, but you can do it on some of the other settings. And if you really want to, you can do the one-click option. The one-click option essentially goes through and does fusion at some sort of general number, overlap detection, smoothing, simplification, and then it goes into meshing with some, general recommended numbers as well. I'm just using the defaults, and I'm kind of clicking OK and going through this quickly. It is always a good idea to double check, especially with things like isolation detection, double check that it's not removing too much. And so what I mean by that is, in some cases, you might find that it's actually taking away a part that you need, just simply based on the fact that it's got kind of a lower resolution or a lower number of points. And so we'll take that. And then the last one here, once again, we'll go to isolation. Sometimes isolation can take away the complete base if we're lucky. I'll actually show you a little bit of a trick here as well. So if your part is up off of the base, so I'll just do this. If your part is up off of the base, what you can do is select the part. So there's this option here where we can select connected. And so basically it will highlight everything that's connected to the main body we scanned. And then we can invert that and then delete the rest of the base. So if it's not connected to the base, it's a quick way to get rid of it. If it is connected, like in the first orientation, then just using the basic polygon tool and cutting across will help. Now, another thing that I would generally do, which is a giant pain without a mouse, is clean up these corners. These corners are going to cause problems. And I think what I probably want to do is get rid of that entire face. And so I'm going to just cut through it. And the reason for that is because when we merge multiple scans together, what's going to end up happening is those are going to influence the final mesh, and we don't want that. So I'm just going to cut that out. Probably not a perfect solution. And then for merging, hopefully I've got enough data on all four of them. There's enough unique features here that it should be able to calculate and align them no problem. Sometimes with more gradual curvature, you'll find that it has issues aligning them. With mechanical parts like this, if it has issues, so you can see 3 of them appear to align okay, but this other one doesn't, this blue one. And so if some of them align okay, then generally what I will do is generate the model, allow it to create the model from those couple scans, and then we can always do the merge process again with the merged model and the one that was missing. And so now there's some holes in this on this side. And so scan 3, what we can do is preview the alignment and see if now that the other 3 are already aligned, if it can put it in the right place. And you can see now it was able to do that. If we had to do it manually, I'll go ahead and do a manual alignment, even though we don't need to. But if we had to do it manually, basically what we want to do is pick parts on both scans. And so we need to find the orientation. So it's going to be, you want to put it in kind of the same orientation. And then what we're going to do is we're going to pick a point on one and a point on the other. And these work best if they're in 3D. And let me go ahead and clear that because I accidentally clicked again, mouse issues. I'm going to put one up here. It's going to be a different spot in 3D. We can rotate it around, but for me, I'm just going to kind of stick it down here. It's in 3D. And once we have at least 3 points, it'll go through and it'll try to align them. And you can check the alignment over here, and it looks okay. So we're going to generate the model. Most cases with Revopoint, I haven't had to do that. But in this case, that one scan, for whatever reason, was kind of a little funny. And so now we're going to go to meshing, merged to. We'll go to mesh. Again, you can use smoothing and simplification on the points. I generally don't because I think it has more of an impact on the quality of the final model. But we're going to turn this into a mesh. And some of the, actually, you know what? Let's go back. I'm going to go to isolation and rerun isolation because we did have some noise in that scan. And we're going to go to overlap detection. This happens a lot of times when we have scans like this. And the corners, they're going to be messy, but I'm just going to run with it for this example. We're going to do a high quality mesh. Again, the fast mesh will be quicker, but you will lose out on some detail. Grid size right now is 0.24 millimeters. I'm going to allow it to create it at that. And just like with the handguard, what we're going to do is we're going to capture the mesh with that resolution, and then we can do smoothing and cleanup and remesh it and simplify it. It's always a good idea to take those points, or at least I think it's a good idea, to take those points in more of their raw state rather than smoothing and simplifying the points, because I found that it has a negative impact on the mesh. Whereas if we take all the points that we have once we fused them and we merge scans together and turn that into a mesh model, then we can go through and process and simplify. And so as we're looking at it, the model, I didn't do a really good job of capturing down inside. I didn't really pay much attention to trying to capture the inside. You certainly could. We could do another scan and just focus our attention inside there. For this example, I don't think it's worth it because I think the intent still here works. But as we look at it, the scan looks kind of rough. Let me zoom out. It looks kind of rough, but we have to remember this is actually a cast part. It's not smooth, it's not machined, it is very textured on the surface. But what we want to do at this point is run isolation detection again. So make sure there are no mesh points that are floating around. And then if you want to, run through smoothing. And again, that longer video, I talked about what these settings do. The strength is essentially going to allow the triangles to move further. So if you've got two triangles that are coming to a point, increasing the strength will allow it to push that down further. The number of times is going to be the number of iterations it goes through. So if you have a low strength, maybe I don't know if I can see this. If you have a low strength and you have a larger number of times, let's say it'll move this a couple degrees each time and it'll run through. If you have a higher strength number, it might run it down a bit further that first time. And so what I'm going to do is I'll just apply smoothing, allow it to process, just to remove some of those irregularities. We will still have some roughness on corners. And again, that is because I didn't clean up the scans. So when the scan is sitting like this, and we hacked out the corner on this side, really, I should have spent more time doing that. Without a mouse, it's kind of really a pain, so that's why I didn't. But once we have this, then we can go to simplification. And so I'm gonna take this down. So right now we're at 1.4 million. I'm gonna set this to 15%. So this is gonna allow us to process basically all the triangles that we created that are at 0.25. And it's going to drop 20% of that. So we went from 1.4 million to 1.2. going to turn the display on, take a look at the wireframe, and we still have a ton of mesh elements that we can get rid of. In most cases, we can actually go pretty extreme. So I'm going to go all the way up to 79%. In most cases, we can go pretty extreme because the RevoScan software will keep the higher density mesh in the corners of tight transitions, and it will simplify those in the larger, broader areas. And so even taking that down from 1.2 million to 260,000, you can see that we've got a much nicer spread in the mesh. We've got higher density in the corners where we need it, like these fillets. But for the most part, you know, that is a better quality mesh that's going to be smoother. So I'm going to go back to solid, and let's go back to maybe a front view. And so once again, some of the issues that we have, these corners that are a little jagged, stuff that I just didn't spend time scanning, like the inside, those are not an indication of a limitation of the scanner itself or the quality of it. It's just a matter of I didn't spend enough time scanning that stuff. And this is why I say that capture more than you think you need, because you can always omit a scan or cut just a section of it or not use it at all, and that's perfectly fine. In this case, I would have to rescan some more frames, remerge it, and then remesh it. And for our purposes of this video, I don't think it's worth it. But what I'll do now is I'll export this mesh, and we'll go to STL. All of these are triangle meshes. So unless you're exporting something with color, STL is perfectly fine. It is a pretty old format, but we'll call this tstat base. It is a pretty old format, but for our purposes, they're all triangular. If you do an OBJ, it can carry the color data along with it if you're doing a color scan. For the laser, we're not doing a color scan, so it doesn't really matter. So now what we could do is we could take those into something like Fusion or Quick Surface and align it, and then continue to work on it if we want to reverse engineer it or something like that. I know this video is long. I have no idea how long, but hopefully this gave you a better, let's go ahead and do that. All right, let's try that again. First, cocoa. All right, so I know this video was probably pretty long. I have no idea how long I've been recording, but it's 3:30 now. But hopefully it helped you understand the general process of scanning with the Inspire2, both in feature mode as well as laser mode. What I would say is the process we followed here is essentially the same for any of the Revopoint scanners. It's going to be critical that you spend time learning the scanner that you have, understand what the settings do, whether it's on the scanner setup itself, meaning if you're scanning with the laser scanner, the point distance, or you know, how that affects the color display on the screen, or if you're using global markers versus marker tracking, or if you're doing color capture scan or something like that. So playing around with it enough and not just sticking with one setting, but going to the extremes. Set the settings all the way up, set them all the way down, and you know, change the number that you fuse the points at, change the number that you mesh at, and see how it impacts the scan. Now, I've kind of gotten to the point where I use general numbers for most of my scans. So when I'm using laser scanning, I generally set it to between 0.2 and 0.5 millimeters for the display. And again, higher for more broad sort of organic shapes like the handguard. If I'm trying to capture those little details like the vents, I'll set it a bit lower so I can make sure I get enough detail there. And then when I process those, I think about the fuse distance relative to the geometry I want to capture. And so capturing the points at 0.5 doesn't necessarily restrict you to fusing at 0.5 if you've captured more. And so understanding that the amount of time you spend capturing the scan, you know, bringing those points into the computer, has a direct impact on things like the fusion distance. The fusion distance has a direct impact on basic settings like how well smoothing works at the point level or simplification works. And then moving from the point level to the mesh level, if you've got points that are a millimeter apart, so if you've got a fairly large triangle, and you're trying to create a mesh at 0.5 millimeters. It can still do that. It's just going to divide that larger triangle up into smaller triangles, or the larger area between those 3 points into smaller triangles. And so what that means. So unfortunately, the lav mic died right at the end of this video, and it was basically the last couple minutes wrap up. But essentially what I was saying here is that if you capture at a larger point distance and you try to use a higher density mesh, basically making smaller triangles, you can do that. However, it's not going to actually recreate those sharp features or those small details. And so you have to look at the size of the object, the geometry of the object, and what you want to capture. And that's where those settings need to come from. And so it's always better for me to capture a denser mesh or a denser point cloud if possible, because we can always go the other direction with the mesh and smooth and simplify it as needed. But you can't really put the data back into it. So it's always good to capture more than you need at the point level, and then try to keep the point count up rather than using things like point simplification. Now, remember, we are an affiliate. I always forget to put that in the beginning of the videos, but if you are looking to buy and you want to support the channel, you can use our affiliate link. We also have a discount code, which should work on top of discounts run by Revopoint. If you use a discount code without the affiliate link, you'll still get a discount, but it doesn't support the channel. So make that decision. If you want to help us out and support the channel while you're buying, you can use our link. If you have any questions or comments, please leave them on this video. I'll do my best to answer what I can. And as always, thanks for watching, and we'll see you in the next one.